Okay, welcome to part two of this ongoing Magnatone student model hum saga. Um, at the uh, at the behest of a couple of people online in a forum on Facebook, I'm going to undertake a few actions here and test to see if I can mitigate this problem of hum. One of the things that was pointed out by a gentleman named Mike Kantz and also by Lyle Caldwell on this forum was that what we have going here is on the first node of this power rail, which begins here. Now we will remember earlier on in the very beginning of this video, we saw about in this position there was a 4 microfarad cap to ground. Then it went through this 1K, but the cap, there was nothing coming off of this node. It was just a cap to ground and then a 1K. But our first node that was used was this one, and we were going. What it's basically doing is feeding the plate of the 6V6, but it's also feeding the plate. If we follow it back this way, it's also feeding through a 200K resistor the plate of the 6SJ7. And what has been suggested here is that what I've got is some sort of loop happening because we're feeding both plates of both of these tubes from the same node. Therefore, as far as my understanding, this we're getting some interference going on. The hum is not properly being canceled. I think what's happening is the waveforms are probably in phase somehow, and they are building upon one another rather than canceling one another. At any rate, what we're going to do to try to mitigate this and to try to actually test to see if that theory is correct. Again, this isn't the exact schematic. This is the Ray Meany model, which I've featured in another video, but it's very similar. So what we're going to do, just to test this theory, while the amp is basically in the same state that it was whenever it was humming, we're going to leave it in that state, but we're going to make one change, and that is to disconnect this 200K resistor. So essentially, this line will be going nowhere. So we will cut off this 200K resistor from feeding this plate. Now this 6SJ7 is going to be operating not at all. Once we do that, it won't have any voltage on the plate, so it will not operate. Okay, here we are. We have this 200K resistor disconnected from the plate of the 6SJ7, and it's just dangling up here in the air, so we're going to be careful not to touch this while the amp is on. We also have the coupling capacitor disconnected, which leads into the volume pot. So essentially what we've done is we've cut this wire off right here, and we've also lifted this connection here. So this is connected to nothing, and this is no longer connected here either. So what we're going to do is we're going to dial up the variac while it's in this state and see what happens here. There we are. We are at full juice. The volume knob is all the way up, and we no longer have the massive hum. Massive hum is gone, and you actually have to get pretty close to the speaker to even hear anything. I'm hearing a little bit of rustling and so forth, but that could just be because we have stuff dangling. So that definitely is our problem. The power supply, as designed in these early Magnatone amplifiers from the 50s, is simply not up to snuff. I guess I could conclude from this. It's possible, I guess, that this capacitor had something to do with it, but it was actually humming with this in early on as well, so I've completely removed that, and you can see that where that blue capacitor was before, I've just removed it. And what we're going to do is go to something that's more like an early Fender Champ, where we have where we have a standard power rail. The first node of the power goes into plate of 6v6. The second node after the resistor goes into its screen, and then we're going to have another resistor, dropping resistor, and we're going to do something different, probably a plate and then a smaller resistor into the screen of the 6SJ7. I'm assuming Magnatone did it this way because they wanted to try to keep the voltages on the 6SJ7 probably on the plate high as possible, so that you didn't have potentially two dropping resistors before you even start feeding the plate of the 6SJ7. Maybe they thought they were going to get some more power out of the amplifier that way. Not exactly sure, but what I'm going to do essentially is I'm going to remodel the power supply off of an earlier Fender Champ, not this version of the Champ. This is the one with the 12AX7, but I'm going to pick a earlier version, and we'll model the power supply off of that, more or less, and go from there. And I think that's going to mitigate our problem. So fingers crossed. Let's get her wired up and then give it a real test. Okay, we're back with this monstrosity again, and finally, at long last, we have discovered the source of the hum. For me, this has been a long ordeal. I'm very, very thankful to all the people who helped me, give me helpful suggestions, because this was a hair puller that was about to drive me absolutely insane. In the end, one wire needed to essentially be moved from one spot to another, and all I have done is moved. Let's see. Sorry, just a moment. I'm holding the guitar as well. Let's grab a schematic. I'll show you what was moved. Okay. Essentially, all I did was move this wire from this point and tied it in instead to this point. So instead of going here, it's now going here, and essentially in the amplifier, that's just the difference of moving it across the from here over to here instead. So now we actually have a situation where all where the 6v6 screen, the 6SJ7 screen, and also the 6SJ7 plate are all three on the same node. So they're on the second node, and that has taken care of the hum. Actually, you'll hear some hum right now, and this is actually kind of a good demonstration of the importance of shielding. You can see I have a lamp up here. It's a fluorescent lamp shining down, and I can actually greatly affect the amount of hum just by blocking this light with my arm. So kind of interesting. So when we get this in the amp, it's not even going to have that amount of hum. I'm pretty confident. As a matter of fact, I think a little bit earlier I was able to get it to go completely away just by moving my hand in front of it. Not able to do that now for some reason. The phone is plugged in, the camera, it's plugged in there, so I think that's actually contributing as well. See there? Interesting how all this, all these fields and RF signals work, especially when you get things close. And this is this is a power cable running to my phone, but check it out if it gets too close to the input. Look at the difference in noise. So that's a good demonstration of some of the things that can cause different kinds of hum. But the hum that we were experiencing on this was just really bad. It appeared again that I was getting some kind of loop going on because I was feeding both plates with the same node, which is apparently a big no-no, and I know in the future not to ever allow that to happen again. And if I ever get one of these Magnatones, I think again, that will be the first thing I look at, and probably the first thing I modify about it. So yeah, very cool. Now it's time to test this amplifier out and see what she can really do whenever we got the power supply sorted out. One other thing really quickly, you can see here I've actually reinstalled this this 0.05 cap to ground that's coming off the screen. It's actually, you know, to ground, but it's also to the same potential as the cathode. If you look at the Fender 5C1 schematic, which is kind of where I got the idea, just to move this connection from here to here, because that's what the 5C1 does. It actually runs all three of those, both screens and the SJ7 plate off the same node as well. But it shows this connected to the cathode in that amp, and actually we have a different bias. We have 120K here. I think on the 5C1 there's a 75K, and this 10 meg resistor is actually a 5 meg, I believe, in the 5C1. So we should get a little more juice probably out of the 6SJ7 than on a Fender 5C1 champ. But at any rate, this is what was done. I've actually left this cap in as it was supposed to be, and as it also was in the Fender 5C1 champ. So just wanted to clarify that's back in, because I know I said earlier that I'd remove that, but it's back in now. So let's check out some of the tones. Okay, we finally got into the demo stage of this exceedingly long journey, and we finally have this amp in a state where it's playable, where there's no hum. There's a little bit of hum here because I have single coils and I'm right next to the amp, and also I've got a few fluorescent lights, but other than that, there's the hum that we were experiencing before is completely gone, and we're ready to test out the tone. For the purpose of this demo, I'm using a Strat, American Standard, and the volume is all the way up on the amp. 1952 Magnatone student model amp. And also, just for comparison purposes, I've set the 1950 Magnatone Ray, or Magna Electronics rather. At this time they were still Magna Electronics. But this is the Ray Mini model that I've referred to so much in this video, in case you didn't see the other video on this amplifier. You can scroll back through my other videos and find the repair for this one. But here are the two side by side. Yeah, very early 50s champ-like amplifiers. Super cool, California made, all hand wired, point to point, killer amps.